Hi students! Today we're going to be learning how to solve equations with variables on both sides. By the end of this lesson, you will be able to simplify equations and then isolate the variable when we see them on both sides of the equal sign. Let's start with this first example. As usual, we're always going to write the equation first. After we write the equation, we're going to first start by eliminating whatever variable is on the right-hand side. In this case, we have negative 7x. So the inverse of negative 7x is a positive 7x. So I'm going to line up the 7x on both sides. The negative 7 and the positive 7 cancel to give me 0. The negative 2x and positive 7x, I owe 2 x's, but I have 7. So I still have 5 x's, and that is going to be plus the 15. Pause the movie now, copy the equation down, then the inverse operations, and then make sure you are at this step before you continue. Okay, let's keep moving. Now we want to isolate x, so I will eliminate this positive 15. I'm going to subtract the 15 from both sides. These cancel. I now have 5x equals negative 15. Pause the movie, copy these steps into your notes, and then continue to solve this equation. Let's see how you did. From here, you should have divided both sides by 5 and gotten x equals negative 3. Please make sure you have all these steps in your notes titled Example 1, and then move on. Let's try this example. To solve this problem, we are going to need to use the distributive property on both sides of the equation. Copy the problem and then use the distributive property on both sides. Then play the movie again so that you can see if you got the problem correct or not. Pause the movie now. Let's see how you did. Negative 2 times x is negative 2x. Negative 2 times negative 5 is a positive 10. That equals 6 times 2, which is 12, minus, 6 times 1/2. Sometimes I like to write these on the side just to check my work. This is going to be 6 over 2, and I know that 6 divided by 2 is just 3x. Pause the movie now to check your notes. Did you get these the same as I did? If not, go back and correct your mistakes and then push play to continue. We now know the next steps. We did it in the previous problem. We want to get rid of the variable on the right-hand side. Right now on the right-hand side, I can see that the variable is negative 3x. To get rid of a negative 3x, I'm going to put in a positive 3x. And what I do to one side, I have to do to the other. Notice on the other side, I lined up the 3x with the negative 2x because those are like terms. So if I simplify those or combine them, negative 2x and a positive 3x is just x plus 10, and that's going to equal 12 because these 3's cancel. Pause the movie and check your notes to make sure you are caught up and have all of these steps written down as examples. Now this next part is very easy to solve. Because I'm adding 10, the inverse operations are to subtract 10 or put in negative 10. Those cancel, so x is equal to 12 plus negative 10, which is 2. Then of course we can go back, plug 2 in for each of the x values, to see if our answer was correct. Let's move on to the next problem. Let's try these three on your own. Remember, for each one, we want to start by eliminating the variable on the right-hand side. So in this case, I might subtract 2x. I might take away 4.5y, and over here, after I distribute, I'm going to take away the 2z. Pause the movie, solve these three problems, then get them checked by your teacher. Great! Now we're ready to move on. Let's look at some more examples. Try this problem on your own. When you get an answer, press play to check your work. This problem might have tricked you. When I look at this problem, 3 minus 4x equals negative 7 minus 4x, and follow Miss Garcia's rule, I'm going to get rid of the 4x on the right-hand side. So I'm going to add that to both sides. But when I bring my numbers down, I get 3 equals negative 7. I know that 3 cannot equal negative 7, so for this example, I would say that there is no solution. Please copy this sample, example 3, into your notes so that you know what it looks like when there is no solution. Let's try another one. Copy this problem into your notes. Use the distributive property and then solve. When you're finished solving for x, press play and check your answers. Let's see how you did. On this side, you have 6 plus 4, 6x plus 4. And on the right-hand side of the equation, 4 times 3 halves. Let's write that over here, 4 times 3 halves. I put 4 over 1. 4 times 3 is 12. 1 times 2 is 2. 12 divided by 2 is 6. So I know that this actually equals 6x plus, don't forget to multiply the 4 by the 1, which is 4. Now, I'm going to get rid of the 6 from both sides, minus 6x, minus 6x, and I'm going to get 4 is equal to 4. Now, in this case, where 4 equals 4, I could put any number in for these x's, and they would always come up equal. Let me show you what I mean. If I use this part of the equation, 6x plus 4 equals 6 plus x plus 4, let's say that x is 2. 6 times 2 is 12, so 12 plus 4 is 16. As the same as over here, 6 times 2 is 12, and 12 plus 4 is 16. So x could be many different numbers. So with this example, we would say that x has infinitely many solutions, which means there are many different numbers that we can plug in for x. Take a minute, pause the movie, to make sure that you have these notes copied into your notebook. Now try these on your own. Pause the movie, solve 4, 5, 6, and 7, and then get them checked by your teacher.